I put this video together to help some of you out with the first lab that we did for the semester. Some of you were not able to make the first class period, and others were in one of my classes where I had to go really quickly through this information. So just in case you sort of missed it or want to see it again, I'm going through it here. I'm also providing answers for the first 6 pages that we did together. I didn't give you all of these answers in class, so they're here. Laboratory 1 is about measurement and the metric system. And there's an introduction here on page 2. The objectives are for you to review the concepts of length, area, volume, and density, and also to practice unit conversions between metric and English units. So this first section shows you metric units. The basic unit of length is the meter, and 1 meter is 100 centimeters, is 1,000 millimeters. Many of you are familiar with those particular names. If you're not, it's time to start reviewing them and getting to know them. There's also a number of equivalencies down here between different parts of the metric system. On the next page is a helpful guide to understand how to go from one prefix to another in the metric system. In the center of this staircase, you put your base unit, and so that could be meters, which is length, I just mentioned. G is for grams, which is mass, and L is for liters, which is volume. As you go down the stairs, you might use deci, centi, or milli as prefixes to these base units. So you can have a decigram, or a centiliter, or a millimeter. And as it says up here, you'll be converting to smaller units if you go down the stairs, and then you move the decimal point to the right. Going up, we have deca with a K, hecto, and kilo. Now, I'm not going to go through how to use this exactly because I've already done it. Watch the learning video Intro 1B.3 for a very clear explanation. But I will give the answers to the problems on the bottom. I didn't do all the problems with all the classes. So the first one asks you to convert 155 kilometers to meter. So you're converting to a smaller unit, in which case, as it says up here, you're going to wind up moving the decimal place to the right for every step in the staircase. 155 kilometers equals 155,000 meters. Going from centigrams to grams, you're going to a larger unit, so you're going to move the decimal place to the left. 86 centigrams equals 0.86 grams. Finally, going from liters to milliliters is going to a smaller unit again. 2.56 liters equals 2,560 milliliters. The next page shows a different set of conversion factors, and these are from English to metric or metric to English. So for example, the equivalence between meters and yards, or inches and centimeters, or kilometers and miles. Now I've also put this in here. This is not in your lab manual. I want to add it in the future. 1 mile equals 5,280 feet. And that is something that you're going to need to know for the homework part of this exercise. I believe it's on page 8. So it doesn't really fit with the rest of these, but this is something that you do need to know. Okay, so let's look at these examples. Convert miles to kilometers. So what you have to do is look up here for something that equates miles and kilometers. And here's one right here. 1 kilometer equals 0.62 miles. Alternatively, I could have used this one. 1 mile equals 1.61 kilometers. They both work, but I just chose that one. So what you do is you take the number you want to change, 75 miles, you multiply it by the conversion factor, and then you get your answer. Now, how did I know to put kilometers on top and miles on the bottom and not the other way around? Well, I want the miles to disappear. And so miles divided by miles is going to be 1. It's going to disappear. If I had put the miles on the top, I would have had miles squared. And then I would have had kilometers on the bottom. It wouldn't have made sense. So by checking your units, you can always know which way to make your conversion when you're doing these kinds of problems. The next one says to convert centimeters to inches. So up here, there's a 1 inch equals 2.54 centimeter conversion. And the answer is 3.1 inches. Convert 5 feet 5 inches to meters. So I decided to convert everything to inches. And here's an inch and meter conversion factor. And this is what the problem would look like. Now, the other thing that you need to know is how many inches are in a foot. So I happen to know And you probably do too, that 12 inches are in a foot. So 5 feet is 5 times 12, or 60 inches, plus 5. And so that's how I got the 65 inches. The next 2 pages show you about volume, area, and density. Area, if you're going to find an area of something simple like a rectangle, is simply length times width. The area of a circle is a little more tricky, and it's pi times r squared. I don't think we have any calculations that are going to involve this. Then volume, which is a 3-dimensional concept, if we look again at a box or a cube, is length times width times height. The volume of a sphere, again, involves pi r cubed. And I don't think we're going to do anything with volumes of spheres. The metric mass unit is gram. I mentioned that earlier. Mass is not the same as density, as I talked about in class, and as you'll also see on the videos. Density is a mass divided by a volume. How compact is that mass? What kind of volume is it in? If the volume is tiny, the density is big. If the volume is large, the density is small. Here's an example. What is the density of a mineral that has a mass of 25 grams and a volume of 8.5 cubic centimeters? Remember, volume has to have a cubic unit. So density equals mass over volume, 25 grams divided by 8.5 cubic centimeters, and that equals 2.9 grams per cubic centimeter. Those are the units for density, grams per cubic centimeter. We don't simplify them any further. So finally, there are 3 more examples to try. What is the area of a pool at PCC with dimensions 13 by 48 meters? So the area formula is over here, length times width. And so it's going to be 48 meters times 13 meters, or 624 meters squared. Meters times meters give you a square. So make sure area always has a square unit. If the pool in the previous problem is filled to a depth of 0.5 meters with water, what is the volume? So remember, volume is length times width times height. So we have 48 meters times 13 meters times 0.5 meters, or depth. And we get 312 meters cubed. So volumes are always cubed. Finally, one more density problem. What is the density of a mineral that has a mass of 40 grams and a volume of 13 cubic centimeters? So we use the formula, density equals mass over volume. We divide 40 grams by 13 cubic centimeters, and we get 3.1 grams per cubic centimeter. I hope this has been helpful. The next 2 pages, pages 7 and 8, are your lab that you should turn in on the due date.